Hi, this is Nimla Rednam. In this video, we are going to solve the sums from exercise 8.3 from the chapter Algebraic Expressions and Identities, which is the 8th chapter of NCERT textbook class 8. So here we have, we are going to be finding product of a monomial by a polynomial. Okay, either a binomial or a trinomial, any polynomial, we are going to find the product. So for that, you need to recall the distributive law of multiplication over addition, which is nothing but a into b plus c. Okay, it's going to give you a into b plus a into c, plus or minus. If it's a minus here, there will be a minus here, right? So we'll be using that. Only thing is here you have terms which are a combination of numericals and variables, right? So let's look at the try this question here. I have 2x into 3x plus 5xy, right? So when I open this bracket, I'm going to be multiplying 2x with each of the terms inside the bracket. So this will give me 2x into 3x is 6x square, right? And there's a plus sign here. And I have 5 into 2 is 10 and x square y, because x into x is x square and there is one y. So this will be my final answer. So similarly, if I have this, so a square into 2ab is 2a cube b, right? And then a minus sign here because I have a minus here. Coefficient 5, a square c. Okay, so this is how we are going to be multiplying. So instead of binomial, if I have a trinomial, it's simply a plus b plus c. So 3 times you're going to multiply. For example, if you have this sum, what you're going to do is 3p into 4p square is 12p cube. I have a plus sign. 3 into 5 is 15p square, right? And 3 into 7 is 21. So 21p. So that will be your final answer. So this is how you're going to solve the product, find the product of monomial by a polynomial. Now here they have also introduced substitution of the variable over here. If you can see, they are asking you to solve this, right? Which I know, we know how to do this, and then you substitute x equal to 1. Now what is x in this? For example, if you take this first sum, x is a variable, right? That means you can assign any value to x. So they're saying what will be the value of this algebraic expression when I put the value of x as 1. Okay, so what we do then is, first of all, solve this. X into x is x square, right? And x into minus 3 is minus 3x, and then plus 2 as it is. Now this algebraic expression, I have to find the value when I put x equal to 1. So substitution and simplifying gives me x and the value of the expression as 0. So that is how you substitute any given value in the particular algebraic expression. So similarly here they have given this, you will simplify it. How do you simplify? First it is the product over here. Again here also I have to find the product and then write everything. And then now this expression is not the simplified form. So any expression will be in the simplified form when there's nothing left to be further simplified. So here I have like terms, if you can see, minus 21 minus 3. I can simplify it as minus 24y. Similarly, this can be simplified. 12 minus 63 is nothing but minus 51. So after writing this final polynomial, what we are going to do is put y equal to minus 2. Wherever I have y, I am going to put minus 2 and simplify. I'll get the value of the polynomial or the algebraic expression at y equal to minus 2. So that is how you are going to substitute in a given value in the variable, right? Now they're asking you to add. You know how to add, but only thing is, here first I need to write it as an algebraic expression by finding the product. 5m into 3 is 15m minus 5m square. So this, after writing it, I am going to write one below the other and find the product. Find the sum of these two, right? So for example, here I have 15m minus 5m square. The second one is 6m square. I have to write the like terms one below the other, and minus 13m. So now I'm going to add them. I will get 2m and m square. So this is my answer. Standard form, higher degree will come first. So m square plus 2m you can write, right? So that is your answer. That is how you will be solving the sums when you have both the product to be found out, and then you have to do the addition or subtraction what they have asked us to do. The second sum is also the similarly. I have 4y into 3y square is 12y cube and so on. After simplifying these two expressions, what I'm going to do is I will be solving it by writing the expressions one below the other with like terms aligned, right? That will give me the answer. So that is about sums where you have to find both the product and then you have to simplify it using addition that we have learnt in 8.1, right? So this example is also very similar to that. You can quickly go through that. Let's start the exercise. Carry out the multiplication of the given expressions. As you can see, in all these expressions, they have given one monomial and one polynomial. Let's look at the sums first. First sum. First question. 4p into q plus r. So like I said, every term inside the bracket has to be multiplied by the monomial outside the bracket. So this will give me 4pq plus 4pr. So that is my final answer because I can't simplify it any further. There are no like terms. Next I have ab into a minus b. Again, multiply each term inside the bracket with the monomial outside the bracket. So I have a square b minus ab square. Next I'm going to write the monomial first and then the binomial. Okay, because you know you can write it in any order for multiplication because it's commutative. So now I have to multiply everything inside the bracket with this. Now what is this into a? I have 3 a's, so that will become a cube b square plus 7 a square b cube, right? So this is the third sum. Next I have 4a into a square minus 9, right? So now I am going to multiply 4a with each term inside the bracket. This will give me 4a cube minus 36a, right? So that is your answer. Next, fifth question I have 0 into some polynomial. Whatever be the polynomial, answer is going to be 0 because every term that you multiply 0 with will result in 0. So the answer is going to be 0, right? So that is about the first question. Now let's look at the second question. They're asking us to find the product of these two given algebraic expressions. Again, here you can see that we have a monomial and a polynomial, right? So let's look at these questions, and every time I'm going to be writing the monomial first and then the polynomial. You can write it either way. So let's look at the second question. First sum, a into b plus c plus d, right? That means every term inside the bracket I'm going to multiply with a. A into b is ab, a into c is ac, a into d is ad. So that is my answer, right? Second question, 5xy into x plus y minus 5. So again, every term inside the bracket, 5xy into x is 5x square y, right? And then I have 5xy square minus 25xy, right? So that is the answer for the second question. Next I have p times 6p square minus 7p plus 5. So again, each term inside the bracket. This is 6p cube. I have a minus sign here and I have 7p square plus 5p. Correct? So this is the third sum. Fourth sum is 4p square q square times p square minus q square. So I have a monomial outside, multiply it with these terms inside the bracket. Okay, 4 p power 4, p square into p square is p power 4 q square, right? And then a minus sign, and then I have again 4 p square q power 4, correct? So this is your fourth sum. Next I have fifth sum, ABC into A plus B plus C. Now I have a monomial and then a trinomial, right? So this is nothing but I have two A's. So A square BC plus AB square C plus ABC square. So that is your final answer, right? So this is about the second question. Third question, they're asking us to find the product of the given monomials. So here they have given only monomials, but the thing is they have given two or more than two monomials. Okay, so let's look at this. I have third question. So because they're monomials, I know to find the product, I have to look at the coefficients and I have to look at the variable part. So I'm going to write directly 2 into 4 because these are the coefficients. And then there's only one variable which is raised to 2 and then it is raised to 22 and then it's raised to 26, right? So this is nothing but 8. Now how many A's do I have? 26 plus 22 is 48 plus 2 is 50. So 8 raised to 50. That is your answer. Next I have 2 by 3 into minus 9 by 10. That is the coefficient part. And then I have x into x square and I have y into y square, right? So you can simplify this. You'll get minus 3 by 5. I have 3 x's, so x cube, and then 3 y's are y cube, right? So that is your answer. Next I have minus 10 by 3 into 6 by 5. That is the numerical part. P into p cube is p variable and q cube into q, right? So this is minus 4 p power 4 q power 4. So that's your final answer. Next, fourth question is x into x square into x cube into x power 4. How many x's do I have? 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So x power 10 is the answer. So these are the questions from the third sum. Fourth sum, they're asking you to simplify the given algebraic expression and then you substitute the values and find the value of the expression if you substitute the value of the variable as it is given over here, x equal to 3, x equal to half, so on. So let's do the first sum. Fourth question. I'm going to write down the question first. Fourth question. 3x into 4x minus 5 plus 3. Now how do I simplify this? By simplification, I mean open this bracket. 3 into 4 is 12, x into x is x square. I have a minus sign here, 15x, right? So 12x square minus 15x and I have a 3 here, plus 3. Now, what is the value when x equal to 3? That means I am going to put 12 into 3 square. Wherever I have x, I have to put its value as 3, right? 12 nines, okay, 108 minus 45 plus 3. So this is minus 42, which will give me 66. So that is the value when I put x equal to 3. What happens when I put x equal to half? So 12 into half square minus 15 into half plus 3, right? So this is 4, 4 will cancel and I'll get a 3 here. I have 15 by 2 plus 3, right? So this is nothing but 6 minus 15 by 2. If I take the LCM, I'll get 12 minus 15 is minus 3. So minus 3 by 2 is the answer, is the value of the algebraic expression when I put x equal to half. So that is the first sum in your fourth question. Next, I have another expression. First, I'm going to simplify it and then we're going to put the values as they have asked. So I have a into a square plus a plus 1 plus 5. So if I open the bracket, I get a into a square is a cube, a into a is a square, a into 1 is a plus 5. So this is my expression. In the first bit, I want to put a equal to 0. So when I put a equal to 0, this is going to be 0 cube plus 0 square plus 0 plus 5, which is nothing but 5. Right? Next, I'm going to put, next I'll be putting a equal to 1. I'm going to get 1 cube plus 1 square plus 1 plus 5, which is nothing but 8. 1 plus 1 plus 1, 3. 3 plus 5 is 8. Right? Next, I need to put a equal to minus 1. Okay? Minus 1 whole cube plus minus 1 whole square plus minus 1 plus 5, which is nothing but minus 1 plus 1 minus 1 plus 5. Right, which is nothing but 4. So the answer is 4. So now you this is I guess it's introduced to give you a feel of what an algebraic expression, what it means. For example, this is an expression in x, in a, right? What is a? This is a variable. So for each value of a, you are getting some value for the algebraic expression. So what if we were to plot it on a graph? Just think about it. Okay. For each value, if a is on x-axis, for each value of a, you're getting some value on the value of the expression. This is your value of the algebraic expression, right? So how would it look like and what it really is? Slowly trying to put some life into this algebraic expression, and once you get a graph of it, you will understand a lot more about the properties of this particular algebraic expression and so on, which we'll do in higher classes. Next, I have addition and subtraction, but as you can see, first I need to simplify it, that is find the product, and then you will do the addition or subtraction, whatever they're asking us, right? So here I have fifth question, A bit. 3 expressions are given to us. So the first one is P into P minus Q. When I open the bracket, it is P square minus PQ. Okay. The second one is Q into Q minus R. When I open the bracket, it is Q square minus QR. Then I have R into R minus P, which when I open the bracket, it becomes R square minus PR. Now I have to add these 3 and I'm going to add them just as we learnt in the first exercise. What we'll be doing is writing one below the other, right? So first I'm going to write P square minus PQ, correct? So I have P square minus PQ. The second one is Q square. There's nothing, no like term. So I'm going to write it below QR, right? Again, the third one in the third row, there's no like term. So I have to write it separately. So you can see that no single column has more than one term. There are no like terms at all in this. P square minus PQ plus Q square minus QR plus R square minus PR. Now I'm going to write it in standard form. That is P square plus Q square plus R square minus PQ minus QR minus RP. Right? I've written PR as RP. It is one and the same. So this is your first sum of simplifying and adding. Right? Let's look at the second sum. They have given two expressions. First, let us find the product and then we can simplify it. Right? So, I am going to write it down. 2x into z minus x minus y. Okay. When I simplify it, I get 2xz, 2x into z. I have a minus sign here. So, minus 2x square, x into x. Again, I have a minus sign and then I have 2xy. Right? This is my first expression. Let's look at the second expression. 2y into z minus y minus x. Again, let's look at the product. This is nothing but 2yz. I have a minus sign, 2y square, and again minus sign, 2xy. Yx and xy are one and the same. AB and BA are same. Right? So, now I have to align them one below the other. First expression, I am going to write it as it is. I won't rearrange the terms. The second expression, 2yz, you can see there is no 2yz anywhere. Right? Next, y square. Again, there is no y square term. So, minus 2y square in a new column. Xy, I have a term here. So, I am going to align it with this. Now, I am going to add it. I get 2xz minus 2x square minus 4xy plus 2yz minus 2y square. So, this is my answer and I am going to try to put it in standard form. Minus 2x square minus 2y square. Right, and then I have xy term, and then I have yz term, and then I have zx term. Right, this is the standard form. So this is about the second B bit. Next I have subtraction, but first I have to simplify it. Let's simplify, and after simplification, please don't forget that it's subtraction, which means that you have to change the signs from the second row. Right? So, this is the first expression given to us. If I open the bracket, I have to multiply each term inside with this term outside. L into L is L square minus 12 L into M LM plus 15 LN. Right? So, this is the first expression. And the second expression is 4L times 10N minus 3M plus 2L. So, if I open the bracket, 4 into 10 is 40 ln minus 12 lm plus 8 l square. Right? Now, they're asking us to subtract this from this. Right? So, I'm going to write this first. I'll write the first expression as it is without rearranging any term. Next, I'm going to write the second expression. I have 3l square. I'll write it here. Lm term, I'm going to write it here, and ln term, I'm going to write it here. Now, since this is subtraction, I have to change the signs. So, 40 minus 15 is 25. This will get cancelled, and here I have plus 5 l square, right? So, my answer is going to be in standard terms 5l square plus 25 ln or nl, right? So, this is your C bit, and next I have to simplify this term. I have two products and then I have to subtract it, and then from this subtraction I have to subtract a third expression. So here in a sense they are doing subtraction twice, right? So let's look at the first part. So I have 3a into a plus b plus c, right? If I open the bracket, this will become 3a square plus 3ab plus 3ac. Correct? Now, I have 2b into a minus b plus c, which is nothing but 2ab minus 2b square plus 2bc. Correct? Now, this minus this is what they're asking. You can either do it, in a single row, or you can just do the subtraction as we have been doing from the previous exercise. So first I have to write this expression 3a square plus 3ab plus 3ac. Okay, I'll write this below this expression by aligning the like terms. So I have 2ab term over here. B square is a new column minus 2b square, and BC. There is no BC here, so plus 2BC. Now since this is subtraction, I have to change the signs. So I have 3a square plus AB, 3 minus 2 is 1, plus 3AC minus 2b square, okay, plus 2BC, correct? So here the sign, I need to take this as plus and this is minus, because I have reversed the signs as it is subtraction. Now this is the expression for the first part of the question. So here this part is what I have solved. Now this has to be subtracted from this. Okay. So first let me simplify this and then we'll subtract it. So that 4c into minus a plus b plus c is nothing but, when I open the bracket, it's going to be minus 4ac plus 4bc plus 4c square, correct? Now from this I have to subtract this expression, so I will write this below this expression. 3a square I have to write in a new column, right? AB also in a new column, AC will come over here, B square in a new column, B square is 2b square, right? And BC I'll be writing over here, minus 2BC. Okay, so this is my expression, and now I have to, because this is a subtraction, I have to again change the signs, right? So this will give me minus 7AC plus 6BC plus 4C square minus 3A square minus AB minus 2B square. If I write it in the standard form, I will be writing it as minus 3A square minus 2B square plus 4C square, and then I have AB term and BC term and CA term, right? So this is your final answer in the standard. So with this we finish the third exercise 8.3, where we have looked at product, finding the product of a monomial with a monomial or any other polynomial. In the next video we will be solving the sums from exercise 8.4.